Here we have two complex numbers, z1 equals 1 plus 2i and z2 equals 2 minus 3i, and we're going to examine the methods for basic arithmetic with complex numbers by finding the sum and the difference, the product and the quotient of these two numbers. So first, the sum. We have 1 plus 2i plus 2 minus 3i, and all we really need to do is combine the real parts and combine the imaginary parts. So if we regroup and we put 1 plus 2 together to get the real part 3, and we put 2i and minus 3i together to get the imaginary part minus I, and the simplified sum is 3 minus I. Now we try subtraction. The process is basically the same. We have 2 minus I minus 1 plus 2i. The only thing we have to take care to do here is to make sure we distribute that minus sign. That is, we subtract the real part and we subtract the imaginary part. So we get 2 minus 3i and minus 1 minus 2i. Now we put the real parts together, 2 minus 1, and the imaginary parts together, minus 3i and minus 2i. That gives us the simplified answer, 1 minus 5i. Now the product. We just use ordinary rules of algebra to multiply out the product, 1 plus 2i times 2 minus 3i, and applying the distributive property twice, we get 1 times 2 is 2, and 1 minus 3i, 1 times minus 3i is negative 3i, and then distributing the second term, 2i times 2 is 4i, and 2i times negative 3i is negative 6i squared. Now the one special property that we have here in working with complex numbers is that when we square I, we get the real number negative 1. So I, by definition, is the number whose square is equal to negative 1. So now we have 2 plus I minus 6 times negative 1. Negative 6 times negative 1 is positive 6, so we combine that with the real part 2, and that simplified product is 8 plus I. Now our trickiest problem here is doing the division, so if we just write the quotient z1 over z2, we have 1 plus 2i over 2 minus 3i, and that's like a sort of complex fraction. But what we really want to do here is simplify in such a form that we can express it in the standard a plus bi format. The way we do that is multiplying that quotient 1 plus 2i over 2 minus 3i, multiply it by 1 in a special form. The special form is equal to the complex conjugate of the denominator over itself. So 2 plus 3i over 2 plus 3i is a fraction just equal to 1, so we multiply by 1 in that form, 2 plus 3i over 2 plus 3i, where 2 plus 3i is the complex conjugate of that denominator 2 minus 3i. And that just means we keep the real part the same and we change the sign of the complex part. Now, when we multiply out in the numerator, we have 1 plus 2i times 2 plus 3i. This gives us 2 plus 3i plus 4i plus 6i squared. And then we multiply out in the denominator, and we have 4 minus 6i plus 6i minus 9i squared. So in both cases, that's just using the distributive property twice, once for the numerator, once for the denominator. Now we can simplify further by replacing those factors of I squared with negative 1. Now combining the imaginary parts and replacing I squared with negative 1, we have 2 plus 7i plus 6 times negative 1 in the numerator, and 4 minus 9 times negative 1 in the denominator. So then minus 4 plus 7i over 13, or if we do that division term by term, we obtain that final standard form, a plus bi form, negative 4/13 plus 7/13 I. So we see that the real part is negative 4/13 and the imaginary part is 7/13 I.